Okay, so we're going to be talking about combinations today, and we're going to finish up this chapter before going on into the practice problems. Okay, so let's begin. Okay, so a combination is, we differentiate a combination from permutation. There's only one big difference lah. We still want to choose a certain number, okay, but in combinations, we don't care what the arrangement is. Okay, so let's say, for example, in the original example I gave you, let's say you have 3 chairs. Okay, again, you have 3 chairs, but this time let's say all 29 of you. Okay, and I only want to choose 3 students, okay, to sit on those chairs. Okay, so the difference between permutation and combination is, for permutation, the arrangement, who goes in which chair, is important. But for combination, can you turn off your mic, please? Okay, for combination, the arrangement doesn't matter as long as I can pick 3 students. So let's say if I were to pick, Sakina, Suhasri, and Alicia Ren. Okay, for combination, the number of ways is the same. Whether I pick Sakina, Suhasri, or Alicia Ren, or Alicia Ren, Suhasri, and Sakina, or Sakina, Alicia Ren, Suhasri, no, it doesn't matter how. Sorry, it doesn't matter how I pick them for combination. Okay, the arrangement doesn't matter as long as saya sudah pilih diorang lah. So generally generally we find that for the same number that you want to use, okay, the number for permutations is always more than combinations, okay, which we will come to in a while lah. Okay, so by definition, a combination is a group of objects that you choose from a bigger number of objects. Okay, that is what is meant by a combination. You can also think of combination as in the combination of a certain number of permutations. Okay, for example, I said just now, let's say you choose 3 students from our class, and then I chose Sakina, Suhasri, and Alicia Ren. Okay, so these 3 I chose, a combination is I don't care what the arrangements are. Okay, there are actually 6 ways to arrange them, but in combination we don't care. Okay, because combination we are only interested in how many ways to choose the 3 of them, which is only one way lah. Okay, so yes. All right. Next thing, okay. So in general, this is the formula for combination. Okay, which is NCR equals to n factorial over n minus r factorial multiplied by r factorial. Notice that the original permutations formula is still over here, which is n factorial over n minus r factorial multiplied by another r factorial at the bottom here. Okay, now this is the long version of it, which you are also required to know. Okay, let me tell you that a lot of people focus on the calculator part of this. Then bila time exam kan, adalah soalan yang keluar yang memerlukan mereka untuk menggunakan formula ini, they forgot. Okay, they forgot, and then I don't remember whether this formula is in the formula book, but it's so basic that you should know. Okay, n factorial over n minus r factorial is actually the permutations formula. Okay, and then r factorial is just the addition to make it the combination formula. Okay, now if you are going to search for it, sorry. Okay. If you're going to look for it in your calculator, it will be at the divide. Okay, it will be shift, I think divide, I think it's shift divide. Okay, it should be lah. Okay, shift divide. You will see the NCR over there. Okay, so let's take a look at a couple of questions, just for simple ones. Okay, and usually there's no involvement of factorial, as I said, because factorial is involving, like just factorial alone is you want to choose and you want to permutate everything. You want to rearrange, everything that is in there. But usually, for combination, we only involve one formula, which is NCR. Okay, but the same rules apply. You still have to use multiplication rule at certain events. Okay, and then sometimes you will have to do, sometimes you will have to combine with permutation. Okay, which we will come to in a while. Okay, let's take a look at question number 2 first. Okay, let's do a simple one. So a test paper consists of 6 questions. Okay, and if a student can answer any 3 questions, how many combinations of questions are there? Okay, so this is a pretty simple one. Okay, you have 6 questions and you only want to choose 3 questions to answer. So this will be 6C3. Okay, which will give you 20 lah. This is a very, it's a pretty simple formula to use. 6C3, you can straight away calculate this on your calculator and then you will get 20. Okay, so right now what I want you to do on your whiteboard is take a look at question number 3. Okay, and then show me your answers on your whiteboard. Okay, delegation of 3 members is chosen to represent a country. If 7 persons have been shortlisted, find the number of different delegations that can be formed. Okay, pausing recording. Gradually harder and harder. All right, so next question I want to take a look is at question 4. A volleyball team consists of 6 players. How many different volleyball teams can be formed from 10 players? Okay, so this is also a pretty simple one. Okay, you just need to do 10C6. Notice that, okay, why don't you try and calculate 10C6 and 10P6. Okay, there's a very significant difference. You will find out that 10C6 actually is 210. Okay, 210. But 10P6, okay, will give you a very big, whopping 151,200. Okay, so there's a very big difference because ini adalah saya mau pilih 6 orang daripada 10, but I don't care about the arrangement. Okay, the arrangement doesn't matter. That's why 210. But kalau saya pilih 6 orang, lepas itu 6 orang, the arrangement kita mau susun, so every arrangement is a different way. It's a different type of team that can be formed. Okay, so that's why usually in general form, no, not usually, every time, if you have the same numbers, the same N and the same R, okay, so the 10P, sorry, 10P6 will be a much bigger number than the 10C6. Okay, that's a general rule that we need to remember. Okay, so don't be surprised if your answer for C is small, but your answer for P is very big. Because for P, as I said, the arrangements matter. Very, very important. Okay, right. Let's do another question together. Sorry, I mean you do. Take a look at question 6. Okay, I want you to read the question 6 and then show me your answers on the whiteboard once again. Okay, pausing recording. Okay, so the answer for number 6 is 210. I also just want to highlight to you that notice that the working you did is 10C4. Okay, and you also got the answer 210. Guys, take a look at this. If you want to choose 4 people out of 10, there are 210 ways. If you want to choose 6 people out of 10, there are also 210 ways. So you see, as I said, the answer may be the same, the answer may be correct, but as I said before, okay, the working and the thought process behind it, okay, is the one that is the most crucial thing when you come to do permutation and combination. Okay, because you may get the same answer, but if your jalan kerja is salah, is essentially kamu sudah salah lah. Of course, in exam is correct. Okay, in exam we only look at the answers because this is a paper 1 question. Nobody cares about the working. But I'm not interested in just your exam lah. Okay, I'm also interested in your logic process. Okay, so yeah, I'm going to focus on this word a lot. Thought process, thought process, thought process. All right, let's take a look at another one. Let's take a look at a slightly more complicated one. Okay, so a club has 20 members. Okay, in how many ways can a committee consisting of a president, a vice president, and 4 committee members be formed? Okay, I want you to read this question first, and I want you to try to answer this question first. Okay, show me your answers on the whiteboard, and then we'll discuss. Okay, 20 members, you want to choose a president, a vice president, and 4 other committee members. Okay, how would you do it? Pausing. Okay, so the first thing I noticed that a lot of you did was to use 20C6. Okay, because you want to choose 6 people, one is the president, one is the vice president, one is 4 committee members. So there's 6 people you choose from 20. So a lot of you automatically quite jumped into 20C6. Okay, but unfortunately this is not correct because how to choose a president and how to choose a vice president is very important. Okay, that is one event in itself. And then I noticed that quite a number of you jumped into this straight away because you say, oh, okay, kalau president, there's only one person, so there's one. Vice president, there's only one person. Okay, so that means 1 times 1 lah. So you only need to count for 4 committee members, which is 18C4. Okay, you find that 18C4, okay, will only give you 3060. Okay, which is not the answer we want. Okay, think about it, guys. If there are 20 people, how many ways are there to choose one president? Okay, it is actually 20C1. Okay, how many ways to choose a vice president? It will be 19C1. Why is this number 19? Because after you've chosen the president, there's only 19 people left. You cannot have the president menjadi the vice president also. So this is the case. If you use 20C6, means it doesn't matter to you. Just choose 6 people and then only give them the post. Okay, which is not what the question is asking. Okay, the question is asking very specifically. First choose the president, then choose the vice president, then choose the committee members. Okay, and then if you notice 20C1 it's not 1, Okay, 20C1 is actually should be 20. No, should be 20. Okay, then 19C1, and then only, as the rest rightly put, is 18C4. Because after you've chosen the vice president and the president, they cannot be considered committee members. And then I noticed some of you put plus. Okay, 20C1 plus 19C1 plus 18C4. Okay, but remember, plus is if the events are not dependent on one another. But every event here, dia bergantung kepada, this event depends on the one before. This event depends on the one before. So we don't use plus. Okay, we use multiply. So 20C1 times 19C1 times 18C4 will give you 116,280. There are 1,162,800 ways to choose a president and a vice president and then 4 committee members out of 20 people. So we see here that we still use the multiplication rule. Okay, most of the time when it comes to combination questions, we always use the multiplication rule as opposed to the addition rule. Addition is very rare lah. Addition happens kalau dia punya event is langsung tiada kaitan dengan satu sama lain. That one you need to know. But this one is very logical. If you want to choose the committee member, you have to choose the vice president. If you choose the vice president, you have to choose the president first. So because they are dependent on one another and they happen at the same time, okay, we use multiply. Okay, we still hold on to the multiplication rule. Okay, let's take a look at another one. Question number 10. Okay, I don't know why I skip question number 9. Where did question number 9 go? Okay, it's okay. Question number 10. Okay, so now you have a committee to run school cleanliness campaign is to consist of 5 members to be selected from 8 parents and 3 teachers and the school principal. Now determine the number of possible committees that can be formed if the principal must be one of the committee members. Okay, go ahead, try first. Okay, so everybody has done their work and everything. I just want to highlight this thought process. Alicia's thought process is very good. Okay, she noticed that there's only one principal and you still have to choose one principal. So it's 1C1. Okay, yeah, I know. 1C1 is a waste of time. 1C1 is actually 1 lah. Okay, but this thought process is very important because it's following the situation given. Okay, the principal must be in. Okay, so it's 1C1. Okay, then times, then we want to choose the other 4 people and we don't care whether they're the teachers or they're the parents, you see. So there's 11 people altogether to choose from and then we want to choose 4. Okay, you get the answer 330. Kalau kau pakai 11C4 sahaja, you still get 330. But the thought process is not exactly very accurate. This one is very clear to me that Alicia has put a bit of thought into, oh, okay, how to choose the principal. There's only one principal, we choose one, so it's 1C1. How to choose the rest of the 4 people. Okay, 11C4, because there's only 11 more people left, and then you C4. Yeah, I'm presuming a lot of things. I don't know whether Alicia actually thought this, but to me, if I were an examiner, I would say, oh, okay, this person has the correct thought process. Okay, because she understood that, oh, you have to first choose the principal and then you multiply. I mean, this is a very basic thing, using multiplication rule. Most people, they will just jump straight into 11C4 because they already understand that 1C1 is actually just sama dengan satu. There's only one principal, you want to choose one principal, there's only one way to do it. Okay, so most people will just jump into 11C4. But I want to highlight this because in different situations, you may not get the same situation. Like, one principal choose only one. Okay, so having this thought process is very important. Okay, so good job to Alicia. Okay, if you notice, the rest of you, ada yang, keluta, so pun terikut-ikut. Okay, fine. So, yeah, basically, when we talk about, permutation, combination, I think I have said this word too many times already. Thought process very important. Okay. All right, let's do a couple more. I just want to do 2 more before we end. I hope that we can end soon. Okay, question number 13 first. Okay, so you have 5 identical counters that are printed with a letter each from the word goals. So there's one counter with huruf G, one counter with huruf O, one counter with huruf A, one counter with huruf L, and the last counter with huruf S. Okay, if 3 out of these counters are drawn at random, find the number of possible selections. Okay, notice the words, selections. We don't really care about the arrangement of the choosing. Okay, you just want to choose 3 counters. Okay, so this will give us, this will give us 10C3 lah. Sorry, not 10C3, 5C3. Okay, 5C3, which will give us the answer 10. Because there are 5 counters, you only want to choose 3. Okay, for question B, find the number of code words that can be formed if 4 counters are drawn at random. Okay, now guys, number of code words is a very big clue. Number of code words means every single code word is different, dependent on how you choose the arrangement of this one. Let's say, for example, I choose GOA and L. GOAL and LAOG is 2 different arrangements. Although I choose the same counter, okay, although I choose the same letter, but the counter, the code word is different. Okay, anyone with a password will I testify to this lah. That if you change the words around, okay, the computer or the server will recognize it as a different arrangement. So since there are different arrangements involved, so this one we're talking about permutation. Okay, so you have 5 letters and you want to permutate, you want to choose and you want to arrange 4 letters. Okay, so this will be 120. So this is an example question now where we find that, in the question you have to use both combination and permutation at the same time. I mean, not really at the same time, it's a different question, but it is the same situation. The first situation asks us to use combination. The second situation asks us to use permutation. Okay, so don't be surprised now. Sometimes we find that in the SPM questions, sometimes question A is permutation, question B is combination. It is not a surprising thing. Okay, so question 13 serves to remind us of this. Okay, let's do one last one, question 14. So you have a hockey team that is made up of 5 strikers, okay, 3 midfielders, 2 defenders, and a goalkeeper. For those of you who don't know what a striker and midfielder and defender is, it's just different positions in the football field. Okay, so ini orang lain, ini orang lain, ini orang lain, ini orang lain. Okay, and I don't know, there's 11 people in the football team, fine. So find the number of different hockey teams that a coach can pick from his training squad of 8 strikers, 4 midfielders, 4 defenders, and 3 goalkeepers. This is a very classic soalan. Okay, and once again, I want you to try this out. Okay, and then show me your answers on the whiteboard. This is our last question for the day. All right, so we're looking at question 14, okay? And we remember we have 8 strikers, 4 midfielders, 4 defenders, and 3 goalkeepers. Okay, and I want to once again show you your different thought processes. Quite interesting, you got this 20 over people that have different thought processes. So some of you use this one, since you have 8 people in whatever their position is, and you choose 5, and then 4 choose 3, 4 choose 2, 3 goalkeepers choose 1 goalkeeper. Okay, and some of you think that there are 69 ways to form it because you use plus. Okay, for example, like Jeremy, okay, Jeremy used plus because neither one is dependent on one another. Okay, that's one way of looking at it. Others, so you see, Luther also had the same thought process, but I don't know how he got 72. Okay, I don't know which answer is correct lah. Okay, because the working is the same. Sekali saya dapat the working is the same, but the answer is slightly different. Quite a number of you choose to use multiply. Like for example, Kelly, same situation, 8C5, 4C3, 4C2, 3C1, and you use multiply. Okay, so the question is, which one is correct? Is it multiply or is it plus? Some of you, like I done, like, okay, don't care. Okay, there are 19 people altogether, I only want to choose 11. Because, saya tambah semua, I tambah all the strikers available, the midfielders available, the defenders available, the goalkeepers available. Saya tambah semua, saya main pilih 11 saja. Okay, so this will be 19C11 75582. Okay, a few of you also were in the same thought process. Ethan cheating. Ethan just now was the same as I done. Okay, so and then there are some like Shane. Okay, give me one by one. Okay, so that means there are 4 answers lah. There are 56 ways to choose strikers. There are 4 ways to choose midfielders. There are 6 ways to choose defenders, and there are 3 ways to choose goalkeepers. Okay, so yeah. So the question now is, which one is correct lah? Okay, so actually the one that is correct. Okay, this one is the one that. Oh, sorry, this is also another thought process. Very interesting. Okay, first you choose the 5. This one daripada 19 orang semua. Okay, so almost the same as Aidan's one. Aidan's one tadi is 19 pilih 11 saja. Tapi Sakif is, okay, choose the this one first, and then choose the this one, choose this one. I don't know what is your answer in the end lah. Okay, I haven't personally calculated it myself. Okay, so you have all these different thought processes, but the majority are showing me that we still use the multiplication rule. And actually, this is the correct answer. Okay, the answer is 4032. And the reason why this is because every event is still dependent on one another. If you choose a different 5 people here, you will form a different team already. Then, let's say kalau 5 orang di sini kan, saya pilih 5 orang yang berlainan kan. Okay, it will affect how the team looks like. Okay, it will be a different 5 people altogether as opposed to if I just main pilih 11 orang saja. Okay, this one I also originally thought it's like I don't care lah, but then I realized that the question gave us specific positions. There are some midfielders, some strikers, some defenders. So mesti ada peranan di sana itu. You cannot have the goalkeeper playing the striker position. Okay, if you play football, obviously you know that goalkeeper is supposed to be goalkeeper. Okay, so and then same train of thought with Sakif lah. Okay, if you choose 19, choose 5 means there's a possibility that the goalkeeper can become the striker also, which we don't want. Okay, or worse, the midfielder become the goalkeeper. Okay, that's even worse. Okay, so now I understand now that some of you are using plus. Okay, some of you are using plus maybe because you thought, oh, okay, saya pilih ini striker tidak mempengaruhi saya pilih ini defender, which is true. When you choose the striker, it doesn't affect the choice of the defender or whatever this position is. But the problem is it affects how the team looks like. It affects how the team looks like. If you choose a different set of strikers, it will, it will become a different combination already. Okay, that's why we still use multiply, because it is still the overall picture still depends on the individual choices. Okay, the overall picture still depends on the individual choices. And over here, let's draw a life lesson. Okay, how we end up in life later depends on the choices that we make today. Wow. Okay, so yeah, so life lesson for today: make right choices, people. Okay, don't make good choices, because life is not all about plus plus plus. Okay, how your life turns out to be, okay, is actually dependent on all the choices that you made in the past. Wow, so deep, the life lesson. Okay, actually that's it for today. I have no more questions to give you. In our next class, next week, we will look at the module, the paper one module. Okay, I would suggest that if you want, of course, first finish up the entire paper. Okay, finish up the entire module. Let me see. Do I have the module over here? Yeah. Okay. So finish up the module. So the day I told you to do until page 7, makan. Okay. So today, since we have already finished combinations, okay, today since we have already finished combinations, so go all the way lah. Okay, this is the last one, permutations lah kan. Okay, so page 8, page 9, page 10, 3 pages only lah. Okay, combinations, page 8, page 9, and page 10. Okay, so once you have finished that, okay, and if you want to do the exercises in the paper 1 module, which actually we will be discussing next week anyway, okay, but if you really want to do it, let me tell you what the questions are. Okay, this is the module questions. Okay, in our module, the paper 1 module, okay, Alicia has a question. Alicia asks, what is placed adjacent to each other? Adjacent to each other means next door to each other. So, sebelah, bersebelahan lah. They're placed next to each other. Okay, it's a good question. Okay, good question to ask. Placed adjacent to each other means they're next to one another. Okay, so these are the questions in the module. You can take a screenshot of this if you want, just to know which questions are in this one. Okay, I want you to notice a certain pattern lah. Most of the time, okay, more often than not, permutations and combinations only comes out in one time in paper 1. Okay, that's why it's a very short chapter, because it's only one question, 3 to 4 marks. A lot of people will like, tak payahlah jawab this soalan, it's only 3 marks only, better to concentrate on the ones with the bigger marks. Okay, but I like permutation and combinations, and also the chapter after this, which is probability, because it deals a lot with logical thinking. Okay, and I noticed that a lot of math students don't have that much logical thinking. So, it's a good way to build up the logical thinking. Okay, there are some modules that have 2 questions. Okay, for example, in these 3, A and 25, 23, 24, A and 18. But we see that most of the time, we find that most of the time it is one question. Okay, what about 2 particular cards next to each other? That means this is the module, right? Okay, Alicia is asking me another question. Okay, I'm going to stop here and show you the module. Page 5, question 15. Page 5. 8 different cards. This one, right? 8 different cards are to be arranged in a row. In how many ways are all the cards to be arranged if 2 particular cards must be next to each other? It means there is 2 cards. Okay, there is 2 cards, and the 2 cards must be next to each other at all times. That means this is the one that we did last class, and we said that, okay, if the 2 cards must be next to one another, okay, you choose the 2 cards first, okay, and then you group them together in the bigger arrangement. Okay, but remember that the 2 cards can also be permutated lah, so it's 2 factorial. Okay, so let me see, 8 different cards. You want to arrange all 8 cards, but can. Okay, so you want to arrange all 8 cards. So this will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, but 2 must be together. Okay, alamak. Okay, if 2 must be together, okay, then this one will be 2 factorial lah. Okay, if this is 2 factorial, okay, 2 factorial. So if it's 2 factorial, and then on top of that, you want to rearrange all this one, right? So it's 1, 2, 3, 4, 5, 6, 7. There's 7 groups altogether. This one must always be next to one another. So it's also 7 factorial. Okay, so 7 factorial, then you multiply lah. Multiply with 2 factorial, you should be able to get this answer. Okay, remember guys, if there are 2 cards, if there are 2 things that must be next to each other, especially in permutations, group them together, but permutate on the inside. Okay, before you do the NPR or the factorial on the outside. Okay, any more questions? Okay, if there's no more questions, let me see. There are 22 people here today. Although some of you just came in, but it's okay. All right, everyone. Tomorrow is a holiday, so we don't have any class tomorrow. But anyway, I don't have any class with you tomorrow. Yeah, tomorrow is a public holiday, people. So please don't wake your teachers up and ask whether got class today. Tomorrow is a public holiday. Friday ada class. Okay, Friday ada class dengan kau punya guru-guru sekalian lah. I also want to just remind you. Oh, sorry. Let me stop the recording.